Hi there everyone. Welcome to the video lecture series of double integration. I'm Mayur Gohil. Let us continue our discussion on change of order of integration with the following question in front of you. Here the double integral is given in the order dy dx, so it's type 1 integral. Now we are very much familiar with all the video series that we have seen, and here you see that the innermost integral has two curves involved, that is y equals to x cube and y equals to x square. So let us plot them. When you plot them, so the green curve over here you can see is going to be y equals to x square, that's the parabola, and y equals to x cube, it's the standard cubic curve. Okay, now if you are not familiar while drawing about the curves, I would request you to plot few points and understand which curve will be on the above or the below the x square or the above the x square. Okay, so how the curve is going to take the shape because of the derivative, so you can check that if you are not aware regarding curve tracing topics. Okay, otherwise you can do this very handy in any of your softwares available. Okay, now let us see how to find the intersection points, because you can see there is one intersection point and it is obviously 1 comma 1, but we still need to do mathematically and show it. Okay, so in order to find the intersection points, you have y equals to x square and y equals to x cube, so equate x square and x cube, so you will get the intersection points as x equals to, one of the 2 points will be x equals to 0 and other one will be x equals to 1. Okay, so at x equals to 0 you will get origin, and at x equals to 1 you get a 1 comma 1. Plot them on the diagram, okay, as I have done over here. Now comes the region of integration which we are supposed to shade. As we see that our projection is falling upon to the x-axis. Okay, so it's from 0 to 1, and alright, so the cubic curve is the first curve that is given in the form of dy dx of the order, the type 1 region. So my region over here is obviously going to be this one. This region is what I am going to have. Okay, so this thin blade of leaf kind of region which you can see, that is the region over here that we are going to get. Now we have to change the order of the integration for this. As you can see, it's obviously type 1 and type 2 region both over here. So let us go for changing of the order. Now when I go for change of the order, I'll have dx dy, okay, which is the type 2 region. For that I pass a horizontal line across the region. Now you can see it is entering the green curve first, so that is the y equals to x square, the parabola. So the parabola equation, in order of x equal to, we will be writing it as x equals to square root of y, and we are going to take positive square root because we are in the first quadrant and we have seen which square root we should take, right? We have brewed upon that concept a lot. Now let us go for the further part. Now the line, you can see it is exiting over here at the red curve over here, the y equals to x cube. So again it is in the first quadrant, so when I take the cube root, it's going to give me x equals to cube root of y. That's going to be the equation over here under consideration. Now let us see the projection. The projection is on y-axis, so if you can see, the projection of the region is basically from 0 to 1 over here. You can straightforward write, and so finally we have our final double integral answer with us. So this is the final answer over here. Okay, so I hope you like this example. It is very simple but important example, very much asked all throughout the times in most of the papers, and most of the basic double integral questions are similar in nature. So I hope you like the content, and please hit like button, subscribe to my channel, and share it with your friends, those who are studying double integral and they need this help. So I take your leave till then. Thank you for joining in. Keep solving good amount of mathematics.